Okay, exponential growth versus decay. We're going to be doing a lot of story problems with this. All right, pretty simple, easy to set up, okay, and they're very applicable in my opinion. You will use this quite often. Y equals A times B raised to the X power. A is still your starting amount, and B is your growth or decay factor, depending on what's going on. Okay. A very common example would be, let's say you purchase a home, and that home was $200,000. Okay, but let's say you purchased it in an area where the price of homes are increasing on a yearly basis. Okay, and let's just say the homes in your neighborhood are increasing by about 6% each year. Okay, it's probably a little extreme. All right. Probably, it maybe should be closer to 3 or 4. I don't disagree with that. Okay. But I want to show some bigger gains here, so that's why I made it be 6. But yeah. So let's say you buy a home for $200,000, and it's increasing at a rate of 6% in value each year. Okay. You should be able to write an exponential growth problem for that situation. Okay? The beginning value was 200,000. So that is the value you will use for your A. Something is increasing in value by 6%. Does anybody know then what we would use as our B value to represent growth by 6%?
0.07.
Not quite, because that would actually make it get smaller, wouldn't it?
Oh, yeah.
He said 0.06.
1 plus 0.06.
1 plus 0.06, or in other words, 1.06.
I do remember that.
Because we want this thing to grow by 6%. Multiplying it by 0.06 would actually make it smaller. You would be figuring out how much it's growing by, but then you'd have to go back and add it to the original again. So the faster way is simply just multiply it by 1.06. Because multiplying something by the 1 would keep it the same, plus increasing it by 6% is adding that 0.06 to our 1, so 1.06. So my setup for that equation would be y equals 200,000 times 1.06 raised to the x power, where x would represent years, and then y would represent the final value of the home or whatever after so many years. Okay. So if you want to know, okay, well, what's this house going to be worth in 5 years? Well, what you need to do is you need to take 200,000 times 1.06 times 1.06 times 1.06 times 1.0, because you multiply by 1.06 every year to see its new value, or you just raise it to the 5th power, much faster way to do it. Okay, instead of repeated multiplication over and over and over again. All right. So if you plug in a 5 here for the years, you would figure out how much that house would be worth in 5 years. Okay? Does that make sense? When you're working with growth, your B value is 1 plus the rate. So take the number 1, add the rate to it. So in our case we did 1 plus 6%. 1 plus 6% was 1.06. Okay? What if you were in a neighborhood where the houses were losing value? Let's say they were losing 6% of its value each year. Bless you. Let's say they were losing 6% of its value each year. What would our B value be if something is losing 6% of its value?
1 minus 106.
1 minus the rate, or in this case, 0.94. Okay? Because if something loses 6% of its value, it's still worth how much percent of its value? 94% of its value, right? Okay? So decay, your B value will be 1 minus the rate. You guys remember this from years past?
Yeah.
Okay? If you struggle with something decreasing by a certain percentage, think about when you're shopping. If you have a coupon for 20% off, how much of the original price are you actually paying? 80%, right? Okay? You kind of think about it that way in a sense. So exponential growth versus decay. Any questions on that? Real quick, let me go around here. Let me make sure you have a good understanding. Tell me what the B value would be for the following situations. Okay? Molly, increasing by 12%.
1.12.
Good. Lexi, decreasing by 5%.
0.95.
Good. Julia, increasing by 30%. Good. Becca, decreasing by 60%.
0.4.
Good. Lainey, increasing by 5.5%.
1.055.
Nice, 1.055, good. Parker, decreasing by 1%. 0.99. Colin, increasing by 100%.
2.
2. Dakota, increasing by 200%.
3.
3. And Corbin, increasing by 500%.
6.
Mm-hmm. We okay with that? Sweet. Okay? So exponential growth and decay. If things are growing exponentially or decaying exponentially, if you see story problems about that, you can use exponential growth versus decay, write out the equation, plug in the values, get your answer. Okay? Another place where this comes into play is compound interest.
I'm gonna put this on the next page.
Just a refresher, okay, if you have some sort of savings account, all right, you're getting interest on that savings account. Right now it's next to nothing, all right, but you are getting some sort of interest on that account. And sometimes that interest can be given to you either annually, quarterly, monthly, continuously, okay? That interest is being added to your account different numbers of times throughout the year, depending on how the account is set up, okay? For example, let's say you have $10,000 in some savings account, and let's say it's earning 2% interest, and let's say that interest is being compounded monthly. So in other words, at the beginning of the year you have $10,000 in your account. At the end of January, assuming you haven't taken any money out or put any new money in, the bank will figure out how much interest it needs to add to your account at the end of that month. It puts that money into your account. Then at the end of February, it'll figure out how much interest you earned and put that money into your account, and so on and so on and so on. The interest amount that the bank is giving you, assuming you don't take anything out, all right, and you're not putting anything additional in, the interest that you earn each month is going to do what? Stay the same, increase or decrease?
Increase.
Increase, because after the first month, you're going to have more than $10,000 in it, right? So you'll be getting interest on an amount that's greater than $10,000. Okay, it's not going to be a huge amount because I didn't give you a whole lot of interest here, but it's going to be something. Okay? How would we set up an equation to figure out how much we have after 20 years? Or let me make it a little more realistic. Let's say you have a rich uncle, he gives you 10 grand on the day you're born, it just sits in this account, you're supposed to use it for college 18 years later. Let's just do that. Okay? So what we want to figure out how much this would be worth. It's not going to be enough for college. But
If
What our equation? What do you think our equation would be? Let's just take a guess. This is going to be tough, all right, because I haven't taught you this. I'm seeing what you know, though. See what we can figure out.
10,000 in front.
10,000 in front. I like it. Kind of like our A value, right? Okay.
1.02 in the parentheses for the B.
Ooh, and then is it 12
18.
plus?
Plus 12.
12 times 18 plus x?
Say that again.
I'm not
12 times
sure.
18
12 times 18.
plus
Or something
12
like,
plus
something,
X.
x, 12 times 18x, I don't know.
something of the sort.
Let's set up the equation without the 18 for right now.
Oh.
We'll plug in the 18 later.
Oh yeah, we don't
12
really,
plus X.
so 12 plus x. Maybe.
What's your rationale on the 12 plus x?
You know, the 12 months.
12 months,
Yep.
and you're going to add that to 18 years.
12 times X.
12 times x,
That makes more sense.
because then 12 times x
Years.
would give you how many times you're getting interest. If you're getting interest every month,
Oh yeah.
there's 12 months in a year, and you're doing that for 18
I
years.
forgot that actually.
But we'll leave the 18 out of it, but there's 12 months in a year, so you take 12 times the number of years.
I didn't think about it.
So like this,
Yeah.
you guys think that's right?
Yep.
Yeah.
Okay. Based on the way I wrote the problem, I could see maybe you would be correct. I was going under the assumption you understood that an interest rate is what's known as an annual percentage rate. I was going under that assumption, and that's my fault. I should probably not have done that. Okay? When you see an interest rate that's being applied to your savings account, it is an annual percentage rate. An APR is usually what they'll use those three letters to describe it. Okay? And what that means is, for a year, you will gain 2% interest. Unfortunately, that means you don't get 2% every month.
Then what the heck?
If you're supposed to get 2% interest over the entire year, how much interest then would you get for a month?
Well, 2 divided by 12.
2 divided by 12, right? 2% divided by 12.
Well, couldn't you just find the 2% of 10,000 and add it on top?
That would tell you then,
Because I did.
what? No, you don't want to do that, because then you're only getting 2% of the original amount, and you're getting that at the end of the year. Let me show you, there will be a difference.
Okay.
Okay, so what you're saying is, just take 10,000 times 1.02, whatever that is, that's how much you have at the end of the year?
Yeah, because you said the 2% was what you should end up with at the end.
Okay, do that for me real quick. Or actually, that's just
I think it's 12.
10,200.
Yeah.
Okay.
Would that be some interest?
This would be if you just get your interest at the end of the year.
Yeah.
So January 1, you start with 10 grand, you don't put any money in, you don't take any money out, bank throws $200 in for you at the end of the year.
Yeah.
Okay? That would be different than this. Because here, you're going to get interest after January.
Yeah.
Then, in February, you're going to get interest based on your new amount after January.
So it won't actually just be 2%. Like,
It'll be 2%, but because it's being calculated more often, the percentage you're getting ends up, the amount of money based on that percentage is going to end up being a little bit more than this.
okay.
Because the money grows and the
Well, yeah, the money grows, but it's,
So for instance, okay, take, I'll show you what you'd have after the first month, okay? 2% divided by 12.
Yeah.
Because 2% is how much you're getting over the year, but we're gonna divide that into months, so somebody take 0.02 divided by 12, add that to 1, then take it times 10,000.
Like 10,016.
Right on the money?
0.6.
So we'll just do that for right now. Okay? So in January, you got just a little under $17 worth of interest.
Yeah.
Okay? Now, in February, you're not going to get that same amount of interest.
You're gonna get that.
You're going to get a little more. Because your starting amount is a little more.
Yeah, I got that. I'm getting that. So by December, if you find 2% of your final number, would that be like, I don't know. I'm just getting confused. Never mind. I get what, like, this makes sense. It's just confusing me.
Sure. And we're really close. I'll just show you what we need to do here. Okay? This would be the setup to tell you how much you get after that first month, right? So this is your setup you want to use, and let's just raise it to the 12x power. Because this is how much you get in 1 month, and 12x would be how many months you're getting this amount of interest. Okay? But for instance, okay, if you raise this to the 12th power, that'll be how much you get
A year.
in a year. So somebody do that for me real quick.
$1,020.18.
1,020.18. Oh, so I was actually, this should have been 1,020. Or 10,020. Is that right?
Apparently, yes.
2% of 10,000
Yep.
would just be $20. So this is $10,020, and how much?
18.
18 cents.
18 cents, you said? Anybody else getting that?
$200.
I got
It's
10.
$200. No, the
Yeah.
original, the one on top is still 200,
10,201.
because that's you.
That's what I got.
because you need to take it to 12 before you multiply it. So I had 10,000.
Alright, 1 plus 0.02 over 12. Raise that to the 12th power. Times our 10 grand. Gotta watch our own operations. $10,201.84. $10,200. Okay? So obviously not a huge difference based on the $10,000 amount. If it was a lot more money to begin with, you'd notice a bigger difference. But it's a small difference. And the reason it is a small difference is because, again, you're getting interest calculated more often instead of just once at the end of the year. Okay? So the formula you would use is you'd have to take 1 plus the interest rate divided by how many times in a year it's going to be calculated. So that's why we put 0.02 divided by 12. Because we were getting 2% over the entire year, but that was going to be divided 12 ways because we're getting our interest monthly. And then you're going to raise that to the n times t power, where n is the number of times it's being calculated, and t is time in years. So in our case, 10,000 times 1 plus 0.02 over 12 raised to the 12 times, and we said after 18 years we want to know how much money we were going to have. So this would be your setup to figure out how much money you'll have in 18 years. So let's check it out. So, unfortunately, be only at $14,328
Yep, going to college for a semester.
for a semester. But better enough.
Yeah.
So compound interest, you just got to be a little bit careful. You can't just use a times b raised to the x power unless you figure out what the new b value would be, and this is how you would do that. And then make sure this number here is how many times it's going to be calculated, basically. Okay? So compound interest, again, it's not always going to be 10,000. All right, a lot of times they'll just use, A for the starting amount. Is that okay? That's for compound interest. Again, R is your interest rate. N is the number of times it's compounded in a year. So in this case, it was 12. And T is time in years. So that's compound interest.